Let's say that you are watching these videos at home and decide to make a snack. You decide to go heat up some popcorn in your microwave. When you go to the popcorn and you read on the side, somewhere here, it says that this popcorn has an output of 1500 watts. And you say, whoa, I remember watts from physics. What does that mean? I think it means something like work over time. But what does that specifically mean for the microwave that's operating at 1500 watts? Well, let's say that you just start cooking your popcorn and, I don't know, you leave it in for 2 minutes, equivalent of 120 seconds, and you are operating at its full power. So we could figure out the work that's done by using this microwave, right? We could say 1500 watts is equal to the work or the energy divided by 120 seconds. So we can multiply these two together and figure out the energy or work, the energy dissipated to cook your popcorn. Let's think about this from an electric charge perspective. So if power is work over time, then work, any given work, could change the level of electric potential. So work done will change UE. Just like if I take my pen and I do some work on it to raise it to a new height, I did some work, I raised UE. So the relationship I'm going to say here is that work is going to be equal to the potential energy, whatever that final is, potential energy, given the initial is 0, which we're free to set. So that means that given that voltage is the electric potential energy per charge, well, work must be QV. So, this means that, let's go back to black. Power is QV over T. What do you notice there? You should notice something. There's a relationship that we already have discussed. It's Q over T. That is current. So power really is then IV when we're discussing electric charge in circuits. Power is the current times the voltage. What does this mean conceptually speaking? Well, let's look at a few batteries. Here I've got a C, a AAA, and a AA. All of them have the same amount of voltage difference. But all of their power is different. Meaning that my C battery that has a higher power output for this given fixed voltage will deliver more current or charge per time than my AAA battery will. And all of these have a different voltage than, say, your 9-volt battery. But just comparing these three, we're going to get more current here than here, than AAA. Okay, well, let's re-express power using Ohm's law. Re-expressing power. We're going to put two equations together. We have our power equation, which is I times V, and we also have Ohm's law, which is V equals IR. I just rearranged that from V over R. So power then is I But instead of V, I'm going to plug this in here and say that it's IR, which is I squared over R, or I squared times R. Okay, I could do this again, or power is equal to, instead of I'm going to plug in V over R. V over R times my V, which is V squared over R. That's power, and this is also power. Let's box these. These are pretty important. And this is our power equation as well. All three of these are the same power. This is specifically power that's expended across a resistor. And depending on the given variables that you know, you could solve for a given power choosing these equations. I wouldn't recommend memorizing all of these three. I would recommend memorizing this equation and Ohm's law and walking through, being comfortable with combining these two so that you can solve for power given whatever two variables you know. All right, that's it for re-expressing power. See you guys soon.